Hello. Time to close the doors. I am now going to throw 50 slides of patterns at you, and once you have endured all of these patterns, you will be allowed to leave the room. Does anyone have any complaints? Because if you do, well, doesn't matter. Let's jump straight into things. So here's what I'm going to talk about today, some basic principles that are common to most migrations you'll have to deal with, and then we'll talk about some common patterns. And I'll share two interesting stories from the company I'm currently working at called PayFit. If you like patterns and 50 slides of patterns isn't enough patterns for you, there are more patterns on this website and there are more coming soon. I'm a bit distracted at the moment with some vibe coding side projects, so the progress is a bit slow, but I'll hopefully get back to that at some point when I get bored of vibe coding, which will probably be very soon because Claude Code says a lot of dumb things that annoy me. If you do like patterns and 50 slides isn't enough and the website isn't enough and you want to do this every single day for 8 hours a day, currently hiring at PayFit, here's a couple of roles that might interest you. So let's talk about some principles. If you've got some legacy system and you're modernizing it, you're migrating to a new architecture, what are some of the key principles? The first one is, in my experience, it's very rarely a technology upgrade. We don't just take something, old software, upgrade the tech, and continue life as we were before with just the same thing with different software. Usually, we have to think about what's actually needed in the old software, how much of it's actually useful. Surveys by Pendo, they're talking about up to 80% of the features in your legacy systems are never used or rarely used, so probably need to figure out what that 80% is, right? And don't waste any time migrating what we don't need to migrate. Otherwise, it's going to take more time, more chance of not finishing correctly. Something else that's important with these legacy system migrations is we're very often not just migrating the software. We have a whole stack of things that we might need to modernize at the same time. Very often, we talk about the UI. Well, if we're going to fix the old software, let's fix the old UI as well, because why invest all this effort if it just looks the same to the user? Very often, fixing the UI, simplifying the UI can make the modernization itself easier. As we move down the stack, we have other things that we can improve at the same time. So firstly, the domain model. As systems get older, they start to drift in terms of how the software aligns with how your business actually works. I'll talk more about this shortly, but again, if you've got some legacy software and when you look at the code, it's like, this code doesn't say much about how our business works today. If you're translating between legacy language and your business language, that's what I'm talking about here. And then obviously, we can actually modernize the domain itself as we're going through this migration process. We can look at our business processes and we can just chop stuff, improve stuff, simplify stuff, change how our business works. So we always have to keep these things in mind for each part of our system. How much of this stack do we want to modernize? There's a lot of things to think about. And this is what I was talking about previously about the language. I call this pattern legacy crystallized semantic drift. How to explain this one? I would say, I was talking to a company a while ago, and they explained to me, yeah, when we want to implement some new features, it takes us 6 weeks. 6 weeks to analyze our legacy system, understand what the code does, and then translate that into requirements because the software doesn't align with the business anymore. And that's a very expensive cost. And what kind of happens is this process, when we build some new features for the first time, the business say, yeah, we need to have a triangle in our product. So the developers will build something, you look in the code and you see triangle, class triangle, method, have 3 corners, that kind of stuff. And then as the business evolves, as you support new use cases, you expand into different countries, you realize what your customers want doesn't quite match, you start to evolve these concepts. And now the business say, yeah, well, now we need to have a square. And the developers say, well, we could refactor our code base and replace all this triangle stuff with a square, which would align perfectly with the business, but that might take a couple of weeks or months, and we have to deliver this feature quickly. So what we can do is, we can cut the corner off the triangle, we can turn it, we can bolt it onto this triangle, and what we've got kind of looks like a square, and it's enough to get by. And over time, we start to do these things. As the business evolves, We don't refactor the code to perfectly align with the business. And so if you've got a system that's 10 years old, 15 years old, 20 years old, the amount of this semantic drift can be quite significant, and that's why it's taking 6 weeks to figure out what should we change to implement a new feature. Good example of this is a company called Vinted. Similar story for many companies, probably most companies, a lot of legacy systems. They built a system for women's clothing, and all of the abstractions and the concepts in their code base were about women's clothing. And then they started selling other kinds of products. And it's like, do you refactor the whole code base to have a model that's aligned around these different kind of products? Or do you take this product, this code base that's designed for women's clothing, and hack it and cut some corners off the triangle so you can sell other products? Most of the time, we do that, right? We don't have time to completely refactor the model. And so that's what happens here. And it starts to get difficult over time to add new features because we're building features using concepts that don't really fit together. When we're modernizing, when we're planning a migration, something else we have to think about with the current system is the design of the system itself is probably not optimal, let's say. So in this example here, we have different systems, system X and Y. We've got a bit of domain A's logic over here and a bit of domain A's logic over here. And what we want to get to in our target architecture is something very modular. All the logic for domain A in a separate subsystem, reduce all of the coupling and have clear interfaces. So, coupling and cohesion, we want to get that. Legacy systems don't have it. And when we're modernizing, we want to end up in that situation with a more modular architecture. Final principle I would say is when doing a migration, I think observability is very important. I'll talk more about that shortly, but I think as you're going through a migration, the system actually gets more complex, and if you aren't able to debug it and figure out why it's behaving in a weird way, that's going to be very problematic. So for me, observability is a key point in there. Okay, so let's talk about patterns. Quick disclaimer, when we talk about patterns, these are kind of general descriptions. You can see these patterns implemented quite differently in different code bases. So I will say the patterns aren't prescriptive. They're kind of guidelines, common generalizations, but they will be implemented quite differently in different systems. But still, it can be useful to have these general patterns that give us some general trade-offs to be aware of. So the first one's the strangler fig. Everyone knows about the strangler fig. I did a workshop recently, and for the first 5 minutes, I said, sit in groups of 5 people, list all the migration patterns you know for working with legacy systems, and every single group had strangler fig pattern at the top. The problem is it's not a pattern, it's just a metaphor. Strangler fig just means you build the new system next to the old system, and you gradually migrate bits across. Not really a pattern, just Martin Fowler's personal metaphor. But anyway, what kind of happens with this pattern is people have interpreted it in a certain way, and this particular implementation where you have a router that handles your incoming requests, and the router can decide, should this request be handled by the legacy or the new code? And that is actually a relevant and a useful pattern. However, it's not the only pattern with the strangler fig pattern, not the only implementation of it. And also, this pattern doesn't really address the hard parts of legacy migration. The hard part is data. The worst part is data. This will give you nightmares if you don't think about this and do it properly. And even if you do think about this and do it properly, it will still give you nightmares because it's such a hard thing to do. And we have many choices here for how we can synchronize our systems. So let's just quickly think about why the data is important. If I have some legacy system here, and I have some new code here, and I have my lovely router that can decide where the requests go, from the user perspective, I don't really care which bit of code's handling my request, but I do expect consistency. If I go to this page over here and I see my name's Nick, and I go to this page over here and my name's Matthew, it's like, hang on a minute, why is my name different on 2 different pages? We still have to have things to be consistent across the product. Web app, mobile app, partner integrations, we need consistency. Otherwise, it's just a bad user experience. And so then we have to think about, well, how do we keep things consistent? We can use domain events, we can use change data capture, we can have import and batch jobs, we can have a shared database between our new and our old code. All of these patterns are valid, and they're all just giving you problems in different ways. So which problems would you like to have? Well, let's analyze the two of the most interesting ones. So if we want to synchronize our systems, our new and our old, to make sure the user experience remains consistent and we provide the same information consistently, and we do calculations consistently, what we can do is we can say, we'll publish some events from our legacy system. Let's say like in boring e-commerce, and a user places an order in a legacy system. We want to build a new system that can show the user like the progress of their order. So we build that outside the legacy. How might we do that? The new code needs to know when an order has been placed in the legacy so it can start this order tracking process. What we can do is we can go to legacy system, we can publish an event that says order placed. Very easy in principle. In practice, it's quite difficult for various reasons. For example, what if we support different kinds of orders and we're working in 3 different countries? We have to make sure that we go through all the different parts of the code and make sure we publish that event for all of them. It's very easy to not publish an event when you should, or to publish an event when you shouldn't. Because going back into legacy and retrofitting events is very difficult. So what we can do is we can use change data capture instead. We can say, let's not rely on putting events in our legacy system. Too unreliable, too risky, too fragile. We'll just have triggers on our database. Whenever a certain database table is modified, it will synchronize either across to the code or directly to the new database. And this way, it doesn't matter when an order's placed, because we'll always capture every modification in our database. But then you get other problems, because you lose a lot of context with this approach. Like, why is this data being modified? Maybe you might get mixed up with a new order or a modification to an existing order. Someone might copy an order. Someone might have some batch job. Someone might create test data. And all of these things can trigger events, and your new system thinks, an order's been placed when it might not have been placed. Equally, you lose a lot of context. When an event is published about an order placed, you might want to add more information to it, but that information might not be easily to put in the database trigger. It might require custom work. So both of these choices can be useful, and both of them are quite horrible at the same time. So let's talk about some other interesting patterns more in the application level. So the first one is the bubble, one from Eric Evans. And as you can see, this is still doing the strangler fig approach, incremental migration. But rather than having a route that directs traffic, you have this new domain model, and that can be your entry point. So the request comes into your new model, and your model decides, will I handle this, or will I delegate it to legacy systems? This is what we call an anti-corruption layer. You translate from your new model to the legacy model. And this can be quite useful if you want to start with a blank canvas, a new domain model, and not have to work in the legacy. But those translation layers can become quite difficult to work with. It can become inefficient for performance reasons. And so it might not work out for you. There's an alternative version of this pattern called the autonomous bubble. And this can address some performance concerns and of the translation issues. So in the first one, usually the databases are still here. Your new bubble doesn't have its own database, or it doesn't have a database that is fully handling all use cases. With the autonomous bubble, your bubble now has its own database. It's able to fulfill requests from its own database. You can address the performance issues, and you don't need the anti-corruption layer to translate between your code. But you've replaced that with this synchronization process. You need to now make sure your database is synchronized with the legacy databases. And sometimes it might be easier to do that, and sometimes it might be easier to do this. That's really where getting into the details counts, and thinking which of these will be easiest, translation in the code or this asynchronous process. And obviously that can be implemented in various ways with different technologies. We then have other patterns. Sometimes you might decide, well, we don't really want to replace the legacy, but we still need to use it. So we can put APIs on the legacy to expose capabilities. We can publish events from the legacy. I actually don't recommend this pattern here, and I'll talk more about that one later, where you have one event from the legacy that goes to multiple consumers. But these are all the options we have to think about. And then, if we're doing an incremental migration, we have to go even more granular. In what order do we migrate things? If I've got a legacy system with 15 APIs or 20 APIs for one domain, I might want to migrate each API endpoint incrementally, one API at a time. Keep it small, keep it safe. That's the best practice, right? Like, do things in very small steps. The problem is, which endpoints do you migrate and in which order? One approach is to migrate your write operations first. You can say, we've got an API for placing an order. We're going to move that to the legacy for the new code first. So a request comes into your new system, the order place happens there, and then you have to synchronize back across the legacy, telling the legacy this order's been placed, because at this point in time, read operations are still going to your legacy. So you start to do a bit of the write operation first. And the benefit of this is, if you want to add new validation rules, new logic, owning the write operation is the key way to do that. You can also go the other way. You can migrate some read operations first. You can say, the legacy system will still handle all modifications or write operations, like placing an order, modifying an order. But we'll have a synchronization mechanism so that the new code can handle the read operations. And this can be quite useful when, for example, database performance is an issue. You'd like to build new APIs with more advanced search capabilities. Migrating the read first can sometimes be quite an easy and obvious first step that allows you to unlock some value. But still, synchronizations have to happen. And if you do this, what you're going to end up with is you might have to do a bi-directional sync. If you start migrating write operations incrementally, then you could be in a situation where it's possible to place an order here and modify an order here, or even place an order here or place an order here and modify an order here and modify an order here. And now you start to hit all kinds of problems like, well, what if someone places an order here and then they modify it here before another modification here has taken place, and now those two modifications are incompatible. Someone's removed an item from their order here and an item from their order here, and now the overall price is minus 100 euros. That shouldn't be possible, but when we do this bidirectional sync, anything can happen. And the validation as well, on our new system, we're probably going to have more strict validation than our old system. How do we handle that? And that's what I call the asymmetrical validation. If you're doing this strangler fig, incremental, migrating operations one by one, the validation can become really problematic. Because if you look at a lot of legacy systems, you're going to find all kinds of data in there. You're going to find someone who's got a name with 1,000 characters in it. You're going to find an email address that's a phone number. A phone number that's an email address. You're going to find everything in there. And your new system's like, what's going on here? What is all this crazy data? Where's this coming from? But at that point, it's too late. You're getting an event that this has already happened in your legacy system. You can't ignore it and say the data's bad. It's already happened. This data exists in your legacy system. You have to accept it. And that becomes interesting from a modeling perspective, because what do we do with data that doesn't meet the validation rules here, but does meet the validation rules here, and it's already happened over here? Yeah, we can ignore it potentially, but now we have a desynchronization. Now we get to the situation where my name's Nick on this page and Matthew on this page. Don't really want that. We can have a situation where we can say, okay, we'll remove the validation from here so both systems have the same validation. So all the benefits of building your new system, you're kind of saying, well, we'll have to throw them away because the legacy system does bad things and we can't work around that. You can try and keep both data. What you can say is, when a request comes in the front door, we do the strict validation. When a request comes in via the back door, we'll allow it. But then in your code, you have to store these different values. And your code has to know, if I've got an email address, if it came from here, it's a real email address. If it came from here, it might not be a real email address. And then you have to do all these branches and switches and checks in your code, which can cause other problems. So asymmetrical validation, I don't hear people talking about this a lot, but this has been affecting me personally for a long time now. It's been a real challenge, and I'll talk more about that later. So those are some general patterns and ideas, just to give you a sense of all the different choices we have. Many more patterns, much more nuances than this. But at PayFit, these are the kind of challenges we've been facing, choices we've had. And I'll quickly explain what Payfit is. So Payfit's pay slips and HR. It's in France, UK, and Spain. And what you can see here is the details page of an employee called Nick Tune. Don't hire this guy. He will give you lots of problems. He will talk about patterns all the time, and he will stop you fixing your legacy systems. But it might sound easy, HR and pay slips, but you can see here, to add an employee, there's a 7-step process. There are various laws in France, for example. Every industry has its own laws about salaries and minimum salaries and days off and hours. So it's actually quite a complex thing. Payfit also does like absences. Your manager can manage your time off and things. A lot of these HR functionalities. And I think Payfit probably in the market for companies up to 1,000 employees, so quite focused in that area. But it can still be very complex. A couple of years ago, Payfit got to the point where it had been very successful for 8 years. I think it achieved unicorn status in France. Yeah, they had a good run, but they reached a point with their initial architecture where ability to keep going very quickly was starting to slow down. So getting ahead of the curve, they decided we need to invest in our architecture. Now the company's grown, the product's grown, address some of those issues, so we can continue to go faster. One interesting thing about Payfit is they built and designed their own in-house programming language. And so a lot of the system was built using low code, but not all of the system was built using low code. And that's been a very interesting challenge. I can talk more about this later, but that certainly adds some intricacies and difficulties in doing a migration like this. And that's kind of what I was saying before. You'll see a lot of the patterns I talked about everywhere, but every company and every system is quite unique, and the individual trade-offs can be very different. So basic idea is we want to get to a loosely coupled architecture. Different domains are decoupled. Different teams can work in different code bases without tripping over each other. We can deploy things independently, and the architecture will communicate via events, event-driven architecture. Very, very, very simple idea. Now, the current state, I work in the employee management domain. Employee management domain is the core part of the product where you register your employees and their contracts and things. And the current state of the architecture looks a bit like this. This is kind of like the key overview. So in this domain, employee management, we have bits of logic in 3 different systems. System A is the company monolith. That's a lot of low code in there. That's been around for like almost 10 years, or maybe more than 10 years. 5 years ago, there was an attempt, a first iteration of migrating some of the employee management logic out of the monolith into its own code base. For whatever reason, we're now in a situation where we have System C, which is attempting to do what System B did, and this time to really finish it and to be successful. So we have 3 code bases. And what makes things interesting is in the system company monolith, there are some significant differences between each country. So each country has its own model. In fact, the company monolith, a large part of that is 3 separate systems designed for different countries. And now the target is to be more global. So that's the current state. And what we want to get to is where we have System C as the single place for all employee management logic. And then we have these domain events that go to the company legacy, company monolith, and any other domains. Will we achieve it? I hope so. That's all I can say at this point, but we've got a couple of years worth of progress to share, so I'll let you know how it's going, and then you can decide. But one of the really key things when we talked about all those patterns earlier, those patterns are useful, like we talked about, for solving different problems. And the challenge we had in the employee management team was we had a lot of different kinds of problems. So we had these other domains, like payroll and declarations and time off. They were all saying, well, we want these events from employee management about employees joining a company, signing a contract, all that stuff. Because when we have those events, we can start to do our migration away from the company monolith. We're kind of blocked waiting for your events. We then have other people saying, yeah, we need a new search API. We need to do a more advanced search API. We've got partners who are queuing up, who want an API to be able to search employees and contracts more efficiently. And then we've got the product people who are saying like, well, we want new features as well. We need to improve the product. And so each of these challenges here is telling us, should we migrate parts of the system where we can publish events sooner? Should we migrate read operations first to support those APIs? Or should we migrate write operations first so that will allow us to build new features? So being pulled in different directions. And I'll talk about the choices we made shortly. But I want to quickly talk about the drifting domain model concept I talked about earlier. And we've got a really, really fascinating example here at Payfit. So when Payfit was first created, there was this concept of an employee. And an employee was personal information like your name, your email, all that kind of stuff, and the contract details, what's your job title, what's your salary. And then as the product evolved, so that's the triangle, right? The employee's the triangle. The employee's the triangle. And then as the product evolved, Payfit realized, okay, so now we support one employee who can have multiple contracts. And so you have to create multiple employees for the same employee who has 2 contracts. And it's a bit weird to have the same person appearing twice. So it's not really an employee anymore, it's now called a contract. So they renamed employee to contract. But still, if you look around a lot of the code base, and even in documentation, and even the way people talk, people still use the word to mean employee when they mean a contract. They'll say, I've got this employee ID. And I'm like, no, you don't. You've got a contract ID. Use the right word. But they'll say, well, in the code, it says employee ID. And I'm like, yeah, you're right. OK, fine. And then someone else will say, I've actually got an employee ID. And I'm like, actually, that is an employee ID. That is the employee ID. And I can tell from the format, it's a UUID. But actually, we call an employee ID collaborator ID now. So the word employee and employee ID can mean like 4 or 5 different things. And if you look through the code, you'll see all combinations of this. But what's important is that we have the target model. We've decided that in the architecture we're trying to get to, we have the concept of a collaborator. And a collaborator has one set of personal information. So if an employee has 10 contracts, we're not going to duplicate their personal information in every single contract, because that just leads to problems. The concept of a contract has also evolved. What we now have is the concept of a working agreement. A contract is just one type of working agreement. We have mandate, internship, and some others as well. So the triangles and the squares have really evolved over time, and we've got a real mix in the system, and we have to try and get to this model, which is how the business currently works and describes its concepts. And I'll come back to this shortly, but I just want to clarify at this point, when we talk about synchronizing data between different systems, new and old, it's not just, oh, we take this data from here and we copy it from here to here, because the model changes. In this legacy system, we have the concept of an employee that has personal information. It's called in the legacy system, it's now called a contract, and it has personal information and contract information. What happens if we update the contract in the legacy system? What happens if I update an employee's address, for example? Well, the employee could have 5 contracts over here, each with different personal information. So when one of the contracts is updated over there, I have to decide, do I update the personal information here, or do I ignore it? Which one of those 5 different contracts with personal information is actually the correct one? And so the synchronization is more than data. You have to translate between the different models. So we had a choice, we had some options, and we had to migrate these 2 different entities, what used to be called the employee, and is now moving to collaborator, and also the contract. So with the employee, we decided to do the right model first. We wanted to be able to support new use cases, add new validation, and build new UIs around that. So we had to choose the right approach. To get to that point, we did event storming, we had discussions, RFCs, meetings, but this is a talk about patterns, so I'm not going to go into any of that boring stuff. But what we wanted to start off with is something like this. So we have system A and we have system B. They support read and write operations for employee management. We wanted to implement this new use case called import employees. So that would come into the new system C. and then that would synchronize back across to the other systems. That was the idea. And so we've now got 3 systems involved in this process. So when I said earlier, having a bi-directional sync is very difficult, well, a tri-directional sync is like stupid. Please, if you can avoid getting to this situation, you should avoid it. But obviously, you might not be able to. And if you're in this position, it doesn't mean you've been stupid. It just means, you know, like it wasn't obvious in the past that it would end up here. So it's important to think ahead. And that's one of the important things for me about incremental migration. Yes, we can migrate things in small steps. We can start with a read or write operation. But what I've learned the most doing legacy migrations is you need to be thinking 10 steps ahead, thinking when we start to migrate this from here, how can it break 10 other different things in the company that we're not realizing? That's really important. So the tri-directional sync is very difficult. The problems I talked about earlier, for example, where you modify something, the data can be, you can have 3 different validation rules, and you can have 3 different modifications on the same entity all happening at the same time. So it's very difficult. And in reality, when you map out the individual processes, it can start to look like this. This was an example we had start of this year called doublon. That means duplicates in French. We had some customers calling up saying, why have you duplicated all my employees for? Why does this employee have 4 different versions of himself? Why have I got 4 of them? And it's like, well, let's try and figure out what's going on here. How was the employee created? Was it created in system A? Was it created in system B? Or was it created in system C? Was the employee modified? Which system was it modified in? How did the synchronizations work? We've got checks. We have to check if it's a duplicate, for example. So the record's created in system A, the deduplication logic is somewhere else. So stepping through this whole process is like 4 different databases. We've got synchronization workflows built with AWS step functions. It's very difficult to do all that. And that's the kind of pain you're going to end up in if you do this incremental migration. Like Martin Fowler's like, hey, you build a router, you send your request here or here. And I'm like, no, this is what it really looks like. Don't listen to Martin. So I was talking earlier about observability, and that's really crucial here. Observability is essential. If you're going to end up in that situation, you need to be able to figure out quickly, how do we get into this situation across all these different systems? Since we're doing event-driven architecture and event sourcing at Payfit, we have tools. I can go into the tool, I can type in an employee ID or a contract ID or a collaborator ID, and I can see all the events across all the domains in the whole company, and I can see, okay, yeah, this was done via the import process, but at the same time, and this is what actually does happen, the user will create the employee in the UI, and then they will do the import process from a spreadsheet, and the system will not realize that it's the same employee because the name is slightly different. Maybe this one's a Swedish name with the characters, and this one doesn't have it, for example. Very subtle things like that. That's what can happen here. Datadog is super important, structured logging. So when the synchronization fails, and it happens a lot, we have messages in our DL queue. But we have a global error handler. Whenever a message fails, we always log the full message and the full error. So I can quickly see this synchronization failed, and here's the exact error. If you don't have that, it's really, you know, if you're grepping through log files on a server, I wouldn't want to be you, that is for sure. Snowflake is also very useful. Snowflake allows us to write SQL queries and do cool stuff without find events easily. And what I've been using for the past few months is my AI debug agent. So here's the basic system prompt. It's much longer than this, but here's the idea. You work for this team. You have to help us debug problems. It understands the architecture of our system. It understands these flows. And then it's plugged into all the different data sources that I'm able to access myself, so it can figure out what's gone wrong. I use the Jira MCP server. I can just give it a Jira ticket number, and it's like it goes and fetches a Jira ticket, reads it, summarizes it, analyzes it. I don't even need to open Jira. That already is a great thing about this. I don't even need to open Jira, but sometimes I do because I miss it. But the other tools here, query the event store, query databases, query Datadog, I don't use the MCPs here. I created custom command line tools that encapsulate certain queries and operations. I don't want this thing thinking it's clever, trying to do all kinds of clever things. I prefer to give it standard approaches and guardrails, so it does things in a consistent way. It's deterministic. And the cool thing is you can use coding agents to build these small tools yourself, which make it quite easy. So to give you an example, I recently had a support ticket, and I just threw the JIRA ticket number at this agent. The agent read the JIRA ticket, and it said to me, oh yeah, there's been a problem with the transferring of a contract. Someone created a contract in July, they transferred the contract from one employee to another, and suddenly the contract appears in June. Like, if it was created in July, how can it appear in June? So the agent, I just said, yeah, go do something. He gives me some options and what he thinks is the right approach. I went, yeah, do that. He went to query Snowflake. He found the events in Snowflake, and he said, oh yeah, I found this contract transferred events. And I can see that the end date of the old contract is in June. I found the problem. So now we found the event that indicates a problem. The agent goes and looks through the code base. It has access to all the code bases on my local machine. I run it from one repository, but he has access to all of them. And he goes through the code and he identifies some theories about how this may have happened. Usually it says dumb things, but very often there's some useful information in there. Sometimes it will get the perfect answer straight away, and I'll be like, you're amazing. And sometimes it will come up with some crazy theories, and I'll be like, you're an idiot. And I'll have to do a bit of investigation myself. But overall, very, very helpful, very interesting. And the key thing here is the more you can help it understand your system. What I'm currently working on is I want the agent to analyze the ticket and say what was supposed to happen. What are all the steps in this process? And then I want you to go and look in each different data store to find the proof that this step did or didn't happen. And sometimes it works, but the problem at the moment is the agent has to understand the code base, and it across multiple different code bases, and it makes a lot of errors doing that. It's good, but it makes a lot of errors. So I'm currently working on a system where we generate the architecture of the system from the code itself, and we'll build a graph of the system, and the agent can use the graph rather than having to go through the code. So overall, I would say taking ownership of the right model here for the employee, starting with that approach, definitely did work for us. It helped us to implement the new use case. We started to build our own domain model. We can add new validation. So we can stop bad data being created with the stronger domain rules. But like I was saying, having this extra three-way synchronization can be very difficult and painful. That's something to always keep in mind. So then we talk about the contract entity. We took a different approach here, and I'll explain to you why in my remaining 2 minutes. So like I said earlier, the employee management domain is kind of the entry point. It's the first bit of the process where you configure your employees in contracts. And we have all these other domains that are telling us, we need events from you. We need to do our migration. Give us the events. And we're like, well, we have so many things to fix, and we're fixing the employee. We don't have any time to give you events about the contract yet. What can we do here? So someone said, what if we publish events from the legacy system and we allow all the domains to consume those events, and then when the employee management team's ready, they can re-implement those events, and the other domains can consume it from the employee management team. This way, the other domains get what they need, and the employee management team is not distracted. We actually preferred not to take that approach, and here's the reason why. If here's my legacy model, I should have used a triangle here. I didn't. I used a green apple. But this green apple represents the model in your legacy system, the old model that doesn't align with your business anymore. If you publish events from your legacy and any domain can consume that, they're all going to be coupled to the old model, the old employee management model. And what this means is they're going to have to do their own mapping from the legacy employee management to the new employee management. And then when the employee management team is ready to provide these events, we're going to have to migrate all of these domains from the old events to the new events. And the new events might look very different to the old events. So we were like, we don't want to do that. We don't want to create more work in the future. So what we said is, we'll try and find a halfway solution where the employee management team can build something good enough, but focus on employee. So we publish events from the legacy, and the employee management domain translates those events to the new model, and then publishes it to the other domains. In the future, when employee management starts to produce those events itself, it can move the logic from legacy to employee management. That's kind of an interface, right? All these other domains don't know if the legacy system is involved or not, and we can do the refactorings and migrations behind that. I'll quickly try and finish. Not long to go now. So that was what we decided. We tried this halfway solution. And that's, again, that's the bubble context here. We're building a new model here, and it's like a facade in front of a legacy. We don't have this router that decides. We're using more of a facade approach. I won't talk about that. That's just the internal application architecture. But I'll quickly talk about the challenges. If you're thinking about this pattern, where you publish events from your legacy, and you have something that translates it and then publishes it to the other domains, this can be very painful, because you're building on foundations that you don't control, and those foundations may be very unreliable. Let me quickly check my bullet point list to make sure I hit the key points. So, for example, if someone goes into your legacy system and modifies information in the database directly, it won't publish an event if you're not doing CDC, for example, which we weren't. So then other teams will say to you, hey, you didn't publish an event to us that you were supposed to. And we'll say, oh, someone went to the legacy system and modified the database directly. And they're like, we don't care. You didn't publish the event, so you are responsible for this behavior. This can break, and it's going to be your fault, and you can't just say, oh, the legacy system doesn't work. It's like, no, you've built this adapter layer. Now you are responsible from their perspective. So you get a lot of other problems like that. You might have forgot to publish an event. Someone might say, hey, this employee left the company 6 months ago, but you never told us. And we're like, oh yeah, in the UK, they have this special import process which does a different flow, and we didn't realize we had to publish an event here. Sorry, we've now got 6 months worth of data that hasn't been synchronized properly, so we have to try and fix that. The legacy system can publish duplicate events when you're not expecting it. And PayFit, for example, because things work, you get paid every month, we have a monthly based model. Sometimes someone goes to the legacy system and they will update some record, and we will get an event, the same event, published 10 times because it affects 10 different months. And other teams are like, why are you sending us 10 events? And we'll say, because the legacy system sent us 10 events. And they'll say, we don't care about the legacy system. We are your customer. That's your problem. So basically, this can work, and I'm happy we did it. It does work, but you got to keep in mind how this is going to break in the future. You might feel like, oh yeah, we have these events from legacy, or we can easily add events to the legacy. But in reality, there's going to be a lot of different use cases, a lot of different combinations, a lot of different operations you might not be aware of. And once you start publishing these events, you'll suddenly be aware of them. So I think it was definitely worth it to do this approach. We were able to work on both the employee and the contract at the same time. We were able to unlock other domains, but the maintenance cost was quite high, much more than we expected at the start. So those are the kind of trade-offs there. And that's basically it. I had a few wrap-up slides, but I'll finish here because we're over time. If you have any questions, feel free to contact me at any point. Yeah, enjoy the rest of the conference. Have a good one.